Hello, everyone. As mentioned, my name is Breanne Johnson, and I'm an Environment Development Planner with NCT COG. And today I just wanted to share with y'all a little bit about our work on anaerobic digestion opportunities in our region and practical ways that we can turn our organic waste into usable products like renewable natural gas. Okay, so for those of you that may be unfamiliar with the North Central Texas Council of Governments, NCT COG is a quasi-governmental voluntary association of the municipal and county governments in our region. We assist these governments in collaborative projects that affect multiple municipalities or counties in our region, and also help connect them to state and federal agencies and resources to assist them in their planning and decision making. The COG serves the fourth largest metropolitan region in the United States, so there are often a lot of competing priorities and resource disparities between the cities in our region that we help our member communities sort of navigate to best serve the growing population of our region. Now, this particular project that I'm going to tell you guys about is a joint effort between the COG's Environment and Development and Transportation departments based on our individual roles in our region. I am part of the Environment and Development team, which serves dual functions as the state designated water quality and municipal solid waste planning agency for North Central Texas. And in this role, we are responsible for amending the regional solid waste plan, with organic waste being a major component of our waste stream. We've also taken on the role of exploring new opportunities for organic waste transformation as part of that solid waste management. And then my colleagues in our transportation department are not only the regional planning agency for transportation infrastructure, but they also serve as the host agency for the Dallas-Fort Worth Clean Cities Coalition. And Clean Cities is a national network of planning groups created by the Department of Energy to advance economic, environmental, and energy security goals in urban areas, with a focus on advancing affordable domestic transport fuels and technologies. The main focus of our Clean Cities Coalition is on improving the air quality in the Dallas-Fort Worth Metroplex and transitioning our local fleets to cleaner fuels like renewable natural gas. With those broader goals and functions in mind, the COG saw an opportunity to combine some of these interests into a regional organic waste transformation effort. As many of you know, our region's population is rapidly growing. And with that comes unique challenges for solid waste management in particular. As Laura mentioned in the beginning, North Central Texas only has an estimated 36 years of remaining landfill capacity if current per capita rates of waste continue. And that means that if we are going to extend the life of our landfills, we either need to build new ones, which isn't exactly ideal, or start diverting much more waste than we currently are to other places besides landfills. And a huge portion, about 50% of North Central Texas' current waste stream is organic waste, such as food scraps or yard waste. And so diverting that waste in particular is a major opportunity to extend our landfill life. Organic waste also releases methane when it decomposes in a landfill environment. So shifting that waste elsewhere is a great opportunity to reduce the methane emissions going into the atmosphere. Another major source of organic waste that is increasing in our region is biosolids from wastewater treatment plants. Obviously, as more people move to the area, there's more waste flushed down our toilets, and that waste can be transformed into energy via renewable natural gas. And this renewable natural gas from organic waste presents a huge opportunity for our region as well to continue transitioning to cleaner fleet fuels for municipal and other vehicles like garbage trucks. Even the post office can use renewable natural gas in their vehicles, as well as using renewable natural gas to heat and power facilities like our landfills and wastewater treatment plants. And as you can see in these EPA waste management hierarchies over here on the right, energy recovery and industrial energy use are always much preferred from an environmental perspective to landfill disposal and even composting. With all that in mind, COG and some of our partners throughout the region saw a clear opportunity to combine the challenges of increased organic waste and the need for renewable fuels into a tailored solution for our communities. And so COG has recently received funding from the EPA to conduct the North Central Texas Organic Waste to Fuel Feasibility Study. And this is part of the EPA's program to increase the utilization of anaerobic digestion technology, which I'll describe in the next slide if you're unfamiliar with that. And the overarching goal of this study really is to identify realistic and achievable pilot projects to make organic waste transformation a reality and to create partnerships between our communities, universities, and industry in the private sector to advance these projects. So this image is just a quick overview of the anaerobic digestion process, made much more simple. And this is the crux of what I mean by organic waste transformation. So basically, this technology transforms food waste and biosolids, these feedstocks up here, such as manure, wastewater biosolids, food waste, and other organics, and it transforms those through anaerobic digestion into biogas, which can be used to heat and power our facilities, fuel vehicles, or be injected directly into our natural gas pipelines. And it also creates a digestate product that can be used as fertilizer, much like typical compost. Now, these types of biogas projects are nothing new. They've been happening all around the country over the past few decades, particularly on the West Coast in states like California and Oregon. But as you can see in this red circle, there are actually currently 23 similar biogas projects already in place in North Central Texas. And these existing projects are mostly utilizing agricultural waste as a feedstock, but some are located in our landfills and wastewater treatment plants. And I'll talk about some of those case studies later in the presentation. But basically, these things are already happening. We're just hoping to expand them and get even more of our region's waste diverted into these facilities. As sort of a first step in this feasibility study, COG created a regional biogas assessment white paper last summer, which summarizes the current state of biogas production and organic waste in North Central Texas. And this was through an ongoing grant through the State Energy Conservation Office. And that grant is partially to explore opportunities for food waste diversion. And so this white paper really set the foundation for the future research that we'll be doing with this new EPA grant. And so I'll show you some of the findings of that white paper, which I think are really interesting. One of the major findings of the biogas assessment was that in 2019, roughly 50% of our residential waste composition was organics. So food waste, yard waste, things like that. And the 2020 numbers aren't up here just yet, but from what I've seen, that number has remained pretty steadily at 50%. And about 30% of the total waste stream combined in that 50% is food waste in particular. And then over here on the right, on the commercial side, this EPA data shows that the top generators of excess food in our region, which are responsible for several million tons of food waste per year. And this only shows educational institutions and food manufacturers and processors. Other major contributors include things like corporate campuses, prisons, other facilities like that are serving food, basically. And this map also shows these orange dots. Those are the existing anaerobic digestion facilities that we currently have in our region. And as you can see, the green and blue dots far outweigh these orange dots, and they don't have nearly enough capacity currently to take in all of this waste, so a lot of it is going to landfill. The National Renewable Energy Laboratory, NREL, also has some data on the methane generation potential of all of this organic waste if it was to be transformed into renewable natural gas. As you can see from the national map and this little cutout over here, our area is really a hotspot for methane generation potential based on the sheer amount of organic waste that we have. As I mentioned, we are the 4th largest metropolitan area in the US, so we obviously generate a lot of waste. And if all of that were to be turned into methane generation, we'd have a huge amount of energy available to our region. Similarly, this graph just shows the amount of biogas that is actively being produced and processed by our region's landfills over the past about 10 years. And it shows a huge increase in the biogas capture from the waste in our landfills. And they aren't able to capture all of the methane because landfills are very large and a lot of that is escaping into the atmosphere. So if there's a way to divert the methane producing materials in landfills to a more efficient capture technology, this number would increase even further. And then from a biosolids perspective, this map from the Renewable Energy Lab shows the methane generation potential just from our wastewater treatment plants, with our region being a similar hotspot for potential biogas production based on the volume of biosolids in our wastewater. So another huge opportunity there. Part of the white paper that I mentioned previously was focused on reviewing which of our wastewater treatment plants have existing anaerobic digestion facilities and which have the potential and the right volume of biosolids to be good candidates for new facilities. So the glowing red dots on this map are the 8 facilities in our region with existing digesters, and they process up to 1 megagallons of water per day, of wastewater per day. And in each of these cases, the energy produced by the biogas is used to generate heat and electricity to power the plant. So it's basically a closed loop system. And also some of the ones that are making excess energy are putting that energy back into our local energy grids. And as you can see, the examples, Dallas Southside Wastewater Treatment Plant, Fort Worth Village Creek, and Denton Pecan Creek are some of the larger treatment plants in our region that are utilizing this technology already. So we know anaerobic digestion is already happening in our region, and we know that there's a huge existing potential for expanding this technology and transforming even more waste. But this slide, I think, really shows why this matters from an environmental perspective. As you can see out of each of the fuel sources on this graph, electricity from sludge or biosolids from wastewater recovery facilities and from food waste have negative carbon intensities, which means that they actually reduce the amount of carbon emitted into the atmosphere by diverting organics from landfills, where they release methane during decomposition. And at the right scale, this has a huge potential for reducing carbon emissions and helping cities and companies meet their carbon reduction or net zero carbon goals as outlined in their climate plans. I also wanted to talk a bit about the transportation applicability and how Dallas-Fort Worth Clean Cities fits into this project. Dallas-Fort Worth Clean Cities is one of nearly 100 similar coalitions across the country working to reduce emissions and improve urban air quality and public health, particularly through alternative transportation measures and technologies. So my colleagues in our transportation department work with fleets in our region to advance their light, medium, and heavy-duty vehicles to alternative fuels, to reduce idling, improve fuel economy, and also factoring in new mobility choices and emerging technologies, such as automated vehicles, increased public transit, all that good stuff. So alternative fuels really is one of these key strategies, and that includes renewable natural gas as a replacement for conventional compressed natural gas in vehicles. And we're interested in being able to transition the fleets in our region that are already using compressed natural gas over to renewable natural gas as much as possible so we can get those extra air quality and climate benefits and reduced greenhouse gas emissions while maintaining less criteria pollutants that we're worried about when we talk about ozone and public health and sort of the low-lying atmospheric pollutants. This slide gives a little context to how transportation energy fits into the total energy mix of the United States, or what is referred to as the energy economy. As you can see, transportation makes up about 37% of the total energy consumption in the United States and is the sector with the highest usage of petroleum fuel, which, as we know, is a finite resource that is expensive and environmentally costly to both use and produce. So one way to reduce energy and petroleum use in the transportation sector is by using more fuel-efficient vehicles and more renewable energy sources. In this context, Clean Cities is really focused on promoting alternative fuel vehicles to create that fuel efficiency within Dallas-Fort Worth fleets. As part of the Clean Cities work in the region, the coalition basically interfaces with the individual fleets to consult them on their best fuel ratios and their needs based on the types of vehicles that they have. So a good number of fleets in our region are already using alternative fuels and alternative vehicle practices like idling reduction. And as part of Clean Cities' work with the Department of Energy, we ask that they report their usage in our annual survey. So in 2019, the survey was able to get information from 42 fleets with almost 10,000 alternative fuel vehicles in our region. So this green bit is just showing the impact of those 10,000 alternative fuel vehicles as opposed to hybrid vehicles and other transportation improvements. And when we report these numbers to the Department of Energy, they use a tool called A-Fleet that calculates the emissions reduced compared to if these vehicles were using conventional fuels or were not using idling reduction and those other behavioral practices. And with all of this in mind, our region reduced the equivalent of 3,059 tanker trucks of gasoline and 1.6 tons per day of ozone-forming nitrous oxide. And the vast majority of those benefits are coming from alternative fuel vehicles. This also shows just the disproportionate impact that using renewable natural gas as an alternate fuel can have on greenhouse gas reductions. This graph comes from the Clean Cities annual report, and RNG is in this dark blue color, so you can see that it was responsible for 25% of the greenhouse gas reductions in Dallas-Fort Worth in 2019, even though less than 2% of the vehicles in our fleet are using renewable natural gas. So that's a huge impact for just a small number of vehicles. And if that number of vehicles is able to increase, this impact will just get even greater. I'm not going to go into all of these economic benefits that come with utilizing renewable natural gas and organic waste transformation. But as you can see, there are many cost benefits along every step in the value chain of this technology, in addition to the environmental benefits already described. For example, waste generators like landfills and wastewater treatment plants in particular can offset the cost to dispose of the organic waste by transforming it into fuel and selling that for revenue. From a municipal perspective, these facilities create jobs and reduce the cost to build new landfills and to clean up environmental contamination from wastewater biosolids or landfill waste leaking into our waterways. And then for fleets, this is a much more local source of renewable energy, which can potentially provide a more stable supply of natural gas fuel if these facilities are at the correct scale. And it'll be at a less volatile price, so they don't have to worry about shipping in natural gas through our pipelines from faraway places, and that can be a little less reliable. There are also several federal incentives for switching to alternative fleet fuels through several tax credits for biogas and renewable natural gas production, and utilizing tradable renewable fuel credits. So basically, the startup costs for this are a little bit high, but through grants and other things that we're hoping to look at in this study, the ongoing cost through these tax credits and grants and increased revenue makes this a pretty economically viable solution to some of the environmental problems that our region is facing. Now I want to talk about a couple local case studies that are already doing some of the individual pieces that go into creating a program like this. One in particular is the Fort Worth Residential Composting Pilot Program. So in 2019, the city of Fort Worth launched their residential food scrap collection service with the main goal of reducing waste sent to landfill. And they did this in collaboration with the COG and with Texas Center for Environmental Quality, as well as a local company called Cowboy Compost. So basically, residents of Fort Worth can opt in to this residential composting pilot program. There's a limited number of spots as it is a pilot, but then they can collect all of their food scraps, yard waste, all those types of household organic wastes, and those will be picked up and taken to the Cowboy Compost facility and turned into compost that any Fort Worth resident can go and purchase and use in their garden, or it can be used like by the city, like on the sides of roads, planting trees and things like that. So it's a product that anyone can utilize. And it also serves another purpose of preserving Fort Worth's landfill capacity by reducing the amount of waste sent and also reducing the greenhouse gas emissions from landfill methane. And I believe just a few weeks ago, Fort Worth extended the pilot program to cover an even greater area of the city and to reach even more residents. So it sounds like it's going really well. And this is something that other communities in our region can sort of copy and emulate. And this also sets up the collection infrastructure that can be used rather than sending the food scraps to a place like Cowboy Compost. We can send those to a centralized organic anaerobic digestion facility. Another case study in our region is one of the wastewater treatment plants that I mentioned that is already using anaerobic digestion on site to power their plant, and that is the Dallas Southside Wastewater Treatment Plant. So some of you, if you're in Dallas, whenever you flush your toilet, it might be going here and turning into renewable natural gas. So the Southside plant generates biogas fuel from their wastewater sludge via anaerobic digestion. I think they have about 12 of these large anaerobic digestion tanks on site, and they use the biosolids from their wastewater treatment plants, and they also use used cooking oil from Dallas residents. So Dallas residents can collect their cooking oil and fat and grease and take it to pickup locations, which will then be taken to the wastewater treatment plant and added to the anaerobic digester as an organic waste feedstock. And up to 50% of the plant's power usage is generated on site through these digesters. And this is a huge plant that uses a ton of energy to treat the wastewater. So 50% is a huge amount of electricity they're generating. It also reduces the plant's reliance on the electrical grid. As we saw in our lovely winter storm this past February, the electrical grid can be a bit unstable at times. So being able to generate power on site at wastewater treatment plants, landfills, water treatment plants in general is really great to keep those municipal services running in crisis events like that. And prior to setting up these anaerobic digesters, the treatment plant was just burning off the excess methane that was released from their biosolids. And so that obviously releases methane into the atmosphere as a greenhouse gas. And so switching away from the process of burning the methane is a lot less harmful to the environment. And the last case study that I want to talk about is at the Dallas-Fort Worth International Airport. The airport has been using renewable natural gas since 2016 in their airport vehicles, so like the little carts that take your baggage to the plane and things like that, are utilizing renewable natural gas to reduce the airport's carbon footprint. And this is not the only fleet in our region that's using renewable natural gas, but they're kind of the poster child for it in our region. They kind of paved the way for other fleets to start taking on this technology. And last summer, they completed a case study on the natural gas that they're using, as well as on the amount of food waste that is produced on site that they're hoping to start diverting to anaerobic digestion facilities. And that's something that our study is hopefully going to be helping them with. The natural gas that they're currently using is being sourced from the Dallas McComas Bluff landfill. And this is part of their strategy to move beyond their achievement of carbon neutral status and actually become carbon negative. And so they've already saved over $1 million in operating and maintenance costs through using renewable natural gas instead of compressed natural gas. And they're hoping to switch all of their fleet vehicles to renewable natural gas by 2022. So as I mentioned earlier, NCTCOG is undertaking an EPA grant in the spring to do a North Central Texas food waste to fuel feasibility study, starting in the spring, so it's ongoing currently. And this is a high-level overview of what that study looks like. Just as a reminder, the goal of this study is to advance regional efforts to divert food waste and other organics from landfill to preserve landfill capacity and to look at renewable energy opportunities and evaluate potential to reduce fleet emissions. So merging all of those concepts together is really what this study is looking at. The first step is to evaluate the supply. I showed a little bit of the data that we have so far on how much of our residential and commercial waste streams are organic waste. But through a partnership with University of Texas at Arlington, we're going to dive a lot deeper into those numbers and see where are the hot spots for organic waste supply, which cities have opportunities for collection for that, such as emulating Fort Worth's program, and how we can utilize the existing supply that we have in our region. The next step is creating collection networks, making sure that once we have the supply, we have a sustainable infrastructure in place to move that supply to the facilities. So either through collection trucks, drop-off locations, whichever is most efficient, that's what we're hoping to find out through this study. We also want to study the demand for renewable natural gas. How many fleets exist in our region that have the capacity to use renewable natural gas, particularly in place of conventional compressed natural gas, and how many are looking to transition their fleets toward this. And then the final step of this is looking at the optimal locations for anaerobic digestion facilities. So once we know where the supply is and where the demand is, how do we place these facilities in the optimal location to connect those two pieces, also utilizing the most efficient collection networks that we can. Yeah, so that's a really broad overview of what the entire study is hoping to do. We are in the fairly early stages, but we are hoping to start work on the study component within the next few months once we've hired a contractor and finalized our agreement with the University of Texas at Arlington to get all of this up and running. And then this study will be fully 18 months starting this past March. So it'll end in September 2022. So this is a really long-term project where we're hoping to partner with as many communities in the region as we can, private sector partners, and get everyone's input on what they think the best course of action would be for these pilot projects that we can implement moving forward. Some updates on our regional study. As I mentioned, we began work in spring 2021, and we're partnering with NCT-COG, Dallas-Fort Worth Clean Cities, and UTA, and we'll also be hiring a contractor later this summer. One of our ongoing partnerships in this project is through the Department of Energy's Argonne National Lab, which hosts a renewable natural gas working group, which is a national group of other COGs, other Clean Cities coalitions that can kind of share their experience doing studies like this, share our progress, ask for advice, things like that. And another really cool opportunity that just came up, so I didn't get a chance to put it on this slide, is we have received 40 hours of free technical assistance from the Department of Energy, and in particular from their waste to energy office. And so we are planning to utilize those 40 hours of free technical assistance on a subset of this larger project in a collaboration between the cities of Plano and Louisville, the Dallas-Fort Worth International Airport, and Toyota North America's corporate campus in Plano. So all of those partners, as well as us, will be collaborating on one subset of this that can take Louisville, Plano, Dallas-Fort Worth's, and Toyota's waste and take all of that to a centralized anaerobic digestion facility located conveniently to all of those partners. And yeah, that's a really cool project that I can talk more about if anyone has any questions. But further in this effort, we've hosted 2 regional webinars already with guest speakers from places like the airport, Dallas Southside Wastewater Treatment Plant, just describing their existing projects and also getting input from the various stakeholders in our region who are interested in this, and sort of finding more about what their needs are and how this study can best fit them. And we'll also be hosting our next webinar on July 12th. Don't have all the details for that yet, but if you're interested in keeping up to date on that one, please email me. My contact information will be on the next slide. But that one will be focused on regional food waste collection networks. So we'll be hearing from Fort Worth, as I mentioned, their compost collection network, as well as one of the universities in our region will be talking about their waste diversion efforts. So that'll be a really good one if you're interested specifically in the food waste diversion piece. And that is all I have. Here's my contact information. Again, I'm Breanne Johnson. And if you're interested in viewing any of the past webinars or learning more about our work in North Texas, you can go to this website, conservenorthtexas.org. And on our past events page, you will see the recordings of those previous webinars. So thanks, everyone.
Excellent. That's such fascinating information, Breanne. We do have a couple of questions from James. So he's talking about do you have any comments on what appears to be a trend away from using landfill gas that's generated on site to generate electricity using reciprocating engine generators? So that's one thing, to converting into green fuel. So instead of using it on site as an energy source, are you seeing a trend away from doing that and turning it into green fuels like propane and methane, like for your fleet projects?
I think there is a trend away from that, and I think a lot of it has to do with as our electrical grid energy mix is starting to get a little cleaner. It's still not quite there yet. There's still a lot of usage of coal. But as the electrical grid starts to get a little bit cleaner, sometimes it makes more sense for a facility to use energy from the grid and instead use the natural gas in their vehicles where there aren't as many cleaner alternatives. And it's also, I think, a lot easier to put the renewable natural gas straight into vehicles that are already equipped to use compressed natural gas, rather than basically installing a converter system onto a building to change the renewable natural gas into electricity. Yeah, I'm not sure if that answers your question, but I think that's the kind of things I've heard on that.
No, that's a really good point, especially about the change of the energy grid becoming greener. I had not thought about that. Um, that, yeah, to use that in vehicles, since that's not going to get cleaner, for a couple more decades. I know more electric vehicles are coming out, but the predominant fuel for vehicles is going to be fossil fuels for a while.
Mhm.
So yeah, that's a really important consideration.
Yeah, and
Um,
also for these larger municipal vehicles that we're talking about, the electric vehicle technology isn't quite as widespread yet for things like garbage trucks and other large heavy duty vehicles.
mhm,
And it's also a lot more expensive for a community to replace an existing truck with an electric vehicle than it
right.
is to just use a truck that already has the capacity to take natural gas and instead
Mhm.
just use renewable instead of compressed.
That makes perfect sense. Yeah, and maybe with um, Tesla coming out with the more heavier vehicles like the trucks, the electric trucks, maybe we will start seeing movement on that, but I think it's probably
Mm-hmm.
um, decades away. What really, so my background is in garbage, so I'm really interested in the food waste, using that as a source, using anaerobic digestion. So are they using bioreactors? I know McComas has a bioreactor. Is that how they are capturing that?
I'm not sure on bioreactors. I know that a lot of the anaerobic digesters that are kind of on the market today do all in one. They
Mhm.
capture the gas and transform it into a usable product. Um, but yeah, sorry, I'm not sure about bioreactors.
Okay. Um, uh, yeah, that was really interesting about the wastewater treatment. And you had said that they use one of the things, one of the food stocks that they used was used cooking oil
Mm-hmm.
from the city of Dallas. And I put into the chat that I used to be at Mountain View, and I know that we have a collection point on the west side of campus, um, near the community garden, kind of around the bend from the community garden. It looks like a little barn, and you
Mm-hmm.
can put cooking oil in there. So, if you do your holiday cooking or a big family dinner, you don't want that going down the drain because that causes different problems.
Exactly.
Um, so you can take your cooking oil, and I must stress your cooking oil, not, the oil from changing, the oil in your car.
Mm-hmm.
um, Take that there, and the city of Dallas comes around and collects that. And that's what it's used for. And I did not know what it was used for. So I'm really excited about that. But I think that all of our campuses have one of those. And now that our campuses are reopened as of June 1st, those are accessible again. So,
Yeah,
but
and I know a few of the other communities in our region do have sort of year-round cooking oil collection points, but
mhm,
also NCT COG yearly around the holidays, like you said, runs our annual holiday grease roundup. So if you save all of your cooking oil throughout the year, or you just want to collect it from, say, your Thanksgiving or Christmas cooking,
mhm.
um, we do that annual holiday grease roundup where there's a collection point in pretty much all of the cities in our region. And then same thing, they all go to McCombs Bluff to be used in the anaerobic digester.
That's very cool. That's very cool. As a matter of fact, the city of Dallas has an education program called Cease the Grease.
Mm-hmm.
That sounds disgusting, but when you actually, it's really excellent, excellent information. I love to go to their table when they do tabling events. And we're going to get to do that again soon someday. Get to be in person and all the fun stuff. So yeah, maybe that's another topic that we can have for the sustainable you. So there was a second question from James, and this is really a great question. That he says he understands how this reduces the release of greenhouse gases by capturing that methane. But is there a path toward being net zero that you can see from these projects?
I think it depends on your perspective of net zero. So if a landfill, for example, wants to call themselves net zero, if they're diverting their emissions to vehicles that aren't their own, those emissions become whoever owns the vehicles. But renewable natural gas vehicles actually are very low emitters of greenhouse gases. I'm not sure if there's zero emissions, but I know they are very low greenhouse gas emissions. So I think utilizing, if you can capture 100% of your landfill methane or divert 100% of your methane producing materials from landfill into an anaerobic digester, and then you use 100% of the biogas produced from that in renewable natural gas vehicles, you will get very close to net zero because those vehicles release so little greenhouse gases.
Cool.
So you'd be net zero from that perspective, but there are also many other things in our cities and our businesses and communities that release carbon. So you could make our waste streams net zero, but that alone would not make an entire city net zero, for example.
Now, well, speaking of that, along that net zero vein, the trucks that collect our solid waste, are you seeing a trend into those becoming more running on getting away from fossil fuels?
Yes, yeah, there's definitely a trend towards that. And that's one of the big drivers of this project, is that we were hearing from landfills that they are hoping to transition. They've either started or they're hoping to transition all of their vehicles to renewable natural gas. They basically just need it to be convenient for them to fill the vehicles with renewable natural gas. So another piece of this project is setting up refueling stations so vehicles can go to those refueling stations and just input the renewable natural gas directly into their vehicles. So yeah, we are hearing from a lot of our landfills and other vehicle fleets in our region that they would like to transition to renewable natural gas vehicles if they aren't already. And so that's what we're hoping to help them with.
And I know that that's a huge sticking point with the electric vehicles is, where am I going to be able to recharge this?
Exactly. And that same concern exists with the renewable natural gas vehicles. So it definitely does need to be a convenient option, and those refueling stations need to be located in sort of the optimal spots for them to refuel along their routes.
Right. Yeah. Yeah. Well, and so now I see where that could also be a problem, where you have the groups of citizens, what we call NIMBYs, the not in my backyard, saying, you're not going to put one of those natural gas refilling stations, in my neighborhood, because that could be dangerous and stuff. So how do you, that's a whole nother thing that we are going to have to start thinking about overcoming as that becomes more prevalent. So is there a thought process about, this is great in the interim, but long term, are y'all thinking about moving us toward electric stuff? And if you were to do that, what is the second use that y'all are thinking about for that, for those gases that you're capturing? Have you thought about that?
The perspective, so this is kind of more of a question for our transportation department, but the perspective that I've heard from them is that right now it really has to be a both and approach in promoting electric vehicles and renewable natural gas vehicles, especially as you mentioned before, electric vehicle technology for these more heavy duty vehicles is either a few years out, or as you mentioned, Tesla is developing it now, but they're still very expensive.
Yes.
And those electric vehicles are not going to be cost effective for cities and especially smaller communities in our region for probably decades.
Yeah.
So in the interim, it really does need to be about renewable natural gas where it's feasible and electric vehicles where it's feasible. Right now, it's not an either or.
Yeah. Yeah. It's a process.
Mm-hmm.
Yeah. Yeah. So James says, thank you. Good answers. Thanks so much for the opportunity to ask. So
Thank you for the questions, James.
I don't have any more questions. So thank you so much, Breanne.